plus 1 E minus. This is an oxidation reaction. This thing could be boron, it could be nitrogen, it could be oxygen, it could be hydrogen, things that aren't metals, right? Lots of things undergo oxidation. In corrosion, you'll have an oxidation reaction and a reduction reaction, right? Corrosion is a process. Usually it's the metal that's oxidizing. And so, is oxidation a half reaction or a full reaction? Half reaction, right? And so for corrosion, you would have both an oxidation and a reduction. And usually the oxidation is a metal, which gives up an electron, right? And the reduction is some sort of electron acceptor like oxygen, something that really wants to have an electron. And so corrosion is more a process where you have both oxidation and reduction happening, and it just turns out that you care a lot more about the metal than what happens to the oxygen. You got plenty of time? Yeah, go ahead.
How do you determine the order of the reaction if you only have the reaction off the concentration?
Ah, yeah. So say you have A plus B goes to C plus D. You're trying to figure out the order of the reaction. Do you know from just looking at this equation what the order is? No, you don't know. So you can't figure it out. If I just give you this and say, what's the order of the reaction? You can't do it. You need data. Or you need some extra hints. Like on the homework, I might tell you that it depends both on the concentration of A and B. And it's first order in A and first order in B. And so then you could say, okay, rate equals K, and it depends on the concentration of A and depends on the concentration of B, and it's first order in both. So overall you would say, now it's going to be second order, right? Because I add up the exponents. Or I might tell you that the reaction is second order, and I'll say, give me a rate expression. And so it could be this. It could be this. It could be this. Anything that adds up to 2, right, is the second order. And so then you need data to figure out which one is correct. So you just can't look at it and say, oh, this is second order, or it's first order, or whatever. You need some other information to figure it out. Yeah?
Say there's a reaction where there's one reactant that goes to 2 products.
Mm-hmm.
If you run the forward reaction, then the maximum it could be is like a first order. But if you run it the reverse reaction, could it be a second order?
So you're talking about something like this, right?
Yeah.
So going this direction, it can be 0th order, it can be first order, it could be second order. You don't know. I mean, just because you have one reactant doesn't mean that you know what the rate expression is. And coming this way, it could be 0th order, first order, second order, you don't know. So you need some information. Just because you have one reactant here or 2 reactants here coming the other way, you don't know.
But could the orders be different, one way versus the other?
Oh yeah. So you can write K forward, K reverse. So let's say rate forward is K forward. So if this is the rate expression, what order of the reaction is it? 0. And rate reverse is K reverse times the concentration of B times the concentration of C. What reaction order is this? Second. So yeah, you can have different rates, you know, it all depends. Other questions? Okay, thank you very much. See you on Tuesday.